Hello! In this module, you will learn about some tools and strategies you can use to manage consumption of your resources on AWS. You will learn how to manage resource consumption by using tags and various cost management tools and best practices. You will also learn about utilizing AWS Trusted Advisor and resource tagging to manage resource consumption. This module includes a lab where you get hands-on experience managing resources with tagging. After completing this module, you should be able to identify some cost benefits of cloud computing and manage resource consumption in an AWS account by using tags and various cost management tools. These tools and resources include tagging, Amazon CloudWatch, and AWS Trusted Advisor. You should also be able to describe how to enforce tagging with AWS identity and access management policies. We're ready to go? Let's get started. Hello, you'll now explore tagging and its role in systems operation. A tag is a label that you assign to an AWS resource. It enables you to identify or categorize the resource in a meaningful way. A tag consists of a key and a value which you define. Say you have two Amazon EC2 instances in a development environment. You might assign a tag to both instances with a key of name. You could then assign a key value to each key, like command host for the first instance and database server for the second. That way you can easily identify each instance and their intended purpose. If you create similar instances in another environment like test, you could assign another tag to each instance with a key of environment. You could then assign a value of development or test to each instance as needed. There are a few important things to remember about tags. First, you can only assign a tag to a resource after it is created. Also, tag keys and values are case sensitive. A best practice is to use a consistent naming convention for AWS resources and tags. You also can't edit or delete tag keys or values with the AWS : prefix. These tags are assigned by AWS and are reserved for AWS use. Some tags are propagated or inherited. This is seen in services that can create other AWS resources, such as AWS CloudFormation and AWS Elastic Beanstalk. Generally, when one of these services creates a resource, it tags that resource with a reference to itself. For example, a resource created by an AWS CloudFormation stack automatically inherits the stack's AWS : CloudFormation prefix to the name tag. Finally, you can only create up to 50 tags per resource. Tags with the AWS : prefix do not count against this limit. Another best practice is that tags should represent organizationally relevant dimensions. Here are some common examples that you can use to manage resource inventory, control access, track costs, and automate operations. AWS Config provides predefined, customizable rules to determine if your AWS resources comply with common best practices. These are called AWS Managed Rules. You can customize the behavior of a managed rule to suit your needs. For example, you could use the Required Tags managed rule to quickly assess whether a specific tag is applied to your resources. You can specify the key of the required tag and, optionally, its value. After you activate the rule, AWS Config compares your resources to the defined conditions. It then reports any non-compliant resource. The evaluation of a managed rule can occur when a resource changes or on a periodic basis. For more information about the AWS Config Required Tags Managed rule, search for Required Tags in the AWS documentation. These examples show how you can create a tag and use a tag to query resources with the AWS Command Line Interface, or AWS CLI. The first command creates a tag named Security Check on the instance. It also assigns the value of the current timestamp to the tag. The tag's key and value attributes are specified using the --tags option of the Create Tags command. You can specify tags for EC2 instances and Amazon Elastic Block Store or Amazon EBS volumes. If the call creates both instances and volumes, you can specify distinct tags for the instance and for each associated volume. The second command lists an instance ID and the tag value of all instances in the current region that have a tag named security check. The -- filters option of the describe instances command identifies the key used to filter the query results. The -- query option identifies the data that is returned by the command. Here are two common use cases for tagging. The first one is shutting down and restarting all instances that have a specific tag. The second use case is checking on compliance for tagging policies. The first use case involves tagging all instances so they have an attribute that indicates the environment where they run. Examples of environments can include development, test, or production. To save costs, you can create a script that automatically shuts down development instances on weekends and then restarts them at the beginning of the week. Here, the pseudocode includes instructions for tagging instances or terminating instances that aren't compliant with tagging requirements. In this scenario, a company or division issues a set of policies about the tags that must be placed on running resources. A script periodically examines all instances that run under an AWS account. It also checks that the required tags exist. If an instance does not have the required tags, the instance is terminated for being non-compliant. In practice, companies that implement this strategy usually stagger deployment over several weeks. In phase 1, machines are not immediately shut down. Instead, the tag or terminate script is written so it sends an email message to the IAM user who created the instance. The message warns the IAM user that their instance might be shut down soon because it doesn't comply with corporate policies. In phase 2 of the rollout, instances are actually shut down. An explanation of the shutdown is sent to the IAM user who created the resource. When instances are properly tagged to describe the role and function in an organization, companies can create other automated processes that implement company-wide cost-saving strategies. Companies can also use tags to organize billing reports that reflect internal cost structures and to achieve more accurate reporting for cost allocation. You can also write IAM policies that enforce the use of specific tags. For example, you could use an IAM policy to enforce the use of the department and cost center tags when you create a resource. You could then use these tags to develop more accurate reporting for cost allocation. You can implement your tagging strategy with IAM policies in many ways. For example, you can use an IAM policy to block the deletion of tags required by corporate standards or compliance requirements. You express tagging requirements in an IAM policy through the condition policy element. Here's an example IAM policy that uses the condition element. When an EBS volume is created, the request must include a cost center tag and a department tag. The for all values modifier creates the requirement. The condition policy also specifies the values that are set for the cost center and department tags. For more information about tagging EC2 instances and EBS volumes when they're created, search for Tag EC2 Instances on Creation in the AWS documentation. Let's review some of the best practices for building a useful and effective tagging strategy. One best practice is to use automated tools to manage resource tags, such as the Resource Groups Tagging API. With this API, you can programmatically control tags. For example, you can use the API to tag and untag supported resources. You can also use the API to list all existing tag keys for an account. Additionally, it's important to always use meaningful names for both the tag and key values. These names should be relevant to your project or business needs and be as descriptive as possible. For more information about tagging strategies, search for Tagging Strategies in the AWS documentation. Thanks for watching. See you in the next video.
What are tags and what can I do with them? Each tag consists of a key and a value, both of which you define. You can display tags in two different ways in the Amazon EC2 console. You can display the tags for an individual resource or for all resources. Tags help you manage your instances, images, and other Amazon EC2 resources. Tags enable you to categorize your AWS resources in different ways. For example, by purpose, owner, or environment. You could define a set of tags for for your account's Amazon EC2 instances that helps you track each instance's owner and stack level. We recommend that you devise a set of tag keys that meets your needs for each resource type. Using a consistent set of tag keys makes it easier for you to manage your resources. You can search and filter the resources based on the tags you add.
Hello, let's take a look at how to manage and reduce the cost of your AWS implementation with the AWS Billing Dashboard, AWS Budgets, and AWS Cost Explorer. One of the fundamental benefits of cloud computing is that you pay only for what you need when you need it. AWS provides you with several ways to use your cloud resources efficiently and to reduce cost. To get closer to the goal of reducing cost, you can create scripts or templates so you only run resources when you need them. For example, you can shut down some resources after business hours or during holidays. Here are 4 of the main tools you can use to organize, understand, control, and optimize your AWS costs and usage. You can view the overall status of your AWS costs and usage in the AWS Billing Dashboard. The dashboard provides a Bills page that shows you the most up-to-date information about your usage costs and usage. This information includes your monthly bill and a detailed breakdown of the AWS services that you consumed. With AWS Cost Explorer, you can explore the details of your cost and usage data so you can identify trends, pinpoint cost drivers, and detect anomalies. You can use AWS Budgets, set custom cost targets and usage budgets, which can alert you when these thresholds are exceeded. Finally, you can use Amazon CloudWatch to monitor your usage charges. With CloudWatch, you create alarms to notify you when your usage charges exceed a threshold that you specify. You will most likely use these 2 AWS Billing Dashboard graphs on a regular basis. The spend summary is one of the graphs on the dashboard. This graph shows you how much you spent last month and the cost of your AWS usage month to date. It also shows a forecast of how much you are likely to spend this month. The month-to-date spend by service graph shows the top services that you use the most and the proportion of your costs that are attributed to that service. This graph is useful for identifying AWS services that you might need to investigate further to optimize your costs. Here is the AWS Cost Explorer, where you can view your costs and usage. You can filter and group data along various dimensions, such as service or instance type. The cost and usage report shown here gives you a summary of the services you used and their associated costs. AWS Cost Explorer provides several other reports, like the Reserved Instance Utilization and Reserved Instance Coverage reports. You can use these reports to view data for up to the last 13 months and to forecast how much you're likely to spend for the next 3 months. You can also get recommendations for which reserved instances to purchase. If you have many accounts and you also enabled consolidated billing for AWS organizations, you can use AWS Cost Explorer to view costs across all linked accounts. You can also monitor the individual daily and monthly spend for each linked account. With AWS Budgets, you can set custom budgets that alert you when costs or usage exceed your budget. AWS Budgets uses the AWS Cost Explorer to show you the status of your budgets and to provide forecasts of your estimated costs. AWS Budgets can also notify you when you go over your budgeted amounts or when your estimated costs exceed your defined budgets. You can track budgets at the monthly, quarterly, or yearly level and can customize the start and end dates. You can also send budget alerts via email or through an Amazon Simple Notification Service or Amazon SNS topic. The example highlights the alert notification generated by AWS Budgets when a budget threshold is exceeded. You can also monitor your estimated AWS charges with Amazon CloudWatch. CloudWatch generates an alert when your charges exceed a specified threshold. When you enable the monitoring of estimated charges for your AWS account, the estimated charges are calculated and sent several times daily to CloudWatch as metric data. Billing metric data is stored in the U.S. East Northern Virginia region, and it represents worldwide charges. This data includes the estimated charges for every AWS service that you use, in addition to the estimated overall total of your AWS charges. The alarm triggers when your account billing exceeds the threshold you specify. It triggers only when the actual billing exceeds the threshold. It does not use projections that are based on your usage during the month. If you create a billing alarm when your charges have already exceeded the threshold, the alarm immediately goes to the alarm state. All alarm notifications are sent to an email address via an Amazon SNS topic. Here are 5 overall principles for reducing your costs. By setting custom cost and usage budgets, you take advantage of the pay only for what you need when you need it principle of cloud computing. By right-sizing instances, you reduce the chance of over-provisioning your resources. You can use AWS Lambda so that you pay only for the compute time you consume. If you use managed services, you can remove the operational burden of maintaining the servers. You can also lower your cost per transaction or service by using managed services. Later, you will learn how AWS Trusted Advisor gives you specific advice on how to reduce costs. You can reduce your costs by eliminating waste. For example, the ease of spinning up resources can lead to running unneeded or underutilized resources. You can use CloudWatch metrics and CloudWatch alarms to find those long-running idle instances and shut them down. A CloudWatch utilization graph, such as this example, can help identify instances that are idle or rarely used. You can also use AWS Cost Explorer to find the cost associated with entire projects or initiatives. You can use AWS Cost Explorer to identify the highest cost projects and then prioritize which projects should be examined first for the cost reduction opportunities. Here's an example of a Stopinator script that can automate instant shutdown. These scripts are typically set up to run during the evenings and on weekends. You can also use utility scripts to start resources when you need them, such as at the beginning of the workday. You can develop your Stopinator scripts with a combination of Lambda function and CloudWatch events. You can implement the logic to stop and start an instance as a Lambda function. The event triggers the function according to your schedule. Now, you'll learn how you can further reduce costs with AWS Trusted Advisor. AWS Trusted Advisor is an online resource that provides advice about reducing costs, increasing performance, and improving security. Trusted Advisor scans your AWS environment and compares it to more than 50 AWS best practices in 5 categories. It then provides recommended actions and includes links for taking direct action. Its real-time guidance helps you provision your resources according to AWS's best practices. You can use Trusted Advisor to identify idle resources, such as EC2 instances, underused load balancers, EBS volumes, and unused elastic IP addresses. Trusted Advisor is an essential tool for cost optimization. It provides checks and recommendations to enable you to achieve cost savings. Trusted Advisor offers additional checks and recommendations for high-level support plans, such as business and enterprise support. Here are the 5 categories that AWS Trusted Advisor analyzes for your AWS environment. For cost optimization, you get advice on how you can save money by eliminating unused and idle resources. You also get advice about how to improve performance by checking your service limits, ensuring you take advantage of provisioned throughput, and monitoring for overutilized instances. Trusted Advisor tells you how to improve the security of your applications by closing gaps, enabling various AWS security features, and examining your permissions. The advice also includes how to increase the availability and redundancy of your AWS applications. Finally, you get a list of the services whose usage exceeds 80% of their service limit. For more information about Trusted Advisor, search for Trusted Advisor on the AWS homepage. Thanks for watching. See you in the next video. It's now time to review the module and wrap up with a discussion of a practice certification exam question. In summary, you learned how to manage resource consumption by using tags. You also learned how AWS Config and IAM support the use of tags for resource management. In addition, you learned about several cost management tools like the AWS Billing Dashboard, AWS Budgets, and AWS Cost Explorer. You learned some strategies and best practices for managing resource use, as well as how AWS Trusted Advisor can help you optimize your AWS implementation based on best practices. These management tools and practices can help you achieve one of the fundamental benefits of the cloud computing: paying only for what you need when you need it. Great work. Let's review a sample certification question. Review this sample scenario and find any keywords that will help you identify the correct answer. Here, the keywords in this scenario are highlighted. You can now consider the answer options. Keeping the keywords in mind, review the answer options and try to rule them out based on the highlighted keywords. In this case, the best solution is AWS Cost Explorer. Now it's time for you to complete the Module 10 Guided Lab, Managing Resources with Tagging. You will also complete the Module 10 Challenge Lab, Optimize AWS Resource Utilization. Thanks for watching. See you in the next video.
Hello and welcome. You will now learn about tools and strategies you can use to automate and standardize the deployments of your AWS resources. In this module, you will learn some general principles for managing configurations in the cloud. You will learn best practices for creating Amazon Machine Images, commonly known as AMIs. You will learn how to develop an overall strategy to manage AMIs for your organization. Finally, you review AWS CloudFormation, including common troubleshooting methods for CloudFormation template deployments. By the end of this module, you will be able to identify some of the AWS services for configuration management. You will also be able to describe some of the best challenges associated with cloud deployments and potential solutions to remedy these challenges. You will be able to describe the purpose of AWS CloudFormation. You will also know about some of the errors you might experience with AWS CloudFormation templates. Finally, you will know how to use continuous integration and continuous deployment techniques on AWS. We're ready to go. Let's get started.
Welcome. You'll now learn about configuration management in the cloud. AWS offers you several methods to help configure and manage infrastructure deployed on the AWS cloud. It is important to plan the configuration and orchestration of AWS resources proactively instead of reactively. Resources can span multiple AWS services. Typically, resources include Amazon Elastic Compute Cloud instances, auto-scaling groups, security groups, load balancers, and the other resources that define your infrastructure. Manual configuration of distributed systems is time-consuming and error-prone. It can lead to inconsistently configured systems. The ability to automate, monitor, and track configuration changes is a key component of any configuration management solution. Configuration management provides many benefits. One of the key benefits is that you can automate launching new resources quickly and consistently. Automation is commonly used for deploying configuration changes to running instances in a reliable way. This minimizes unexpected server downtime. The most frequently used configuration management services in AWS are AWS CloudFormation and AWS OpsWorks. Amazon CloudWatch complements these services. CloudWatch provides a monitoring service that can trigger actions when changes to your resources occur. AWS provides several technologies for configuring and deploying your EC2 instances and other AWS infrastructure. This module explores some of these technologies. You will also learn about combining these technologies into a comprehensive configuration and deployment strategy. Here are some of the most commonly used features and resources. For an EC2 instance, you can use the user data mechanism to run scripts when the instance is launched. The use of scripts is one of the most simple approaches to configuration management because it borrows from how most systems are manually configured. At the enterprise level, it becomes difficult to manage and version the control of your infrastructure by only using scripts. You can make provisioning more consistent. For example, you can create Amazon machine images that you customize to the needs of your organization. With AMIs, you can predefine installations and configurations of EC2 instances. This practice reduces your time to deployment. You can also use configuration and deployment technologies like Chef, Puppet, and Ansible. These technologies enable you to configure new instances through reusable templates. They also update configurations dynamically in response to change. OpsWorks is a configuration management service that provides managed instances compatible with Chef and Puppet to perform updates and deployments. And finally, AWS CloudFormation is a service you can use to create and manage your AWS infrastructures. It enables you to configure architectures for repeatable and consistent deployments. One way to approach creating a configuration strategy is to first consider what custom AMIs should be created. In general, baking software into custom AMIs is best reserved for foundational, slow-changing components that are required and are standard throughout the organization. After establishing what will be included in any custom AMIs, the next step is to decide which configuration software to use. You can choose from services such as AWS CloudFormation or AWS OpsWorks to manage the configurable, rapidly changing components that you want to deploy. It is always a best practice to have a version control system. AWS Code Commit can be used to version control the templates and configurations used for the deployment. This is called infrastructure as code. Finally, explore and experiment. Developing an effective configuration management solution is an iterative process where you try an approach and continually improve it. You can improve the approach, the templates, and the infrastructure as code methodology so that your solution becomes more effective and efficient. Thanks for watching. See you in the next video.